The outside structures, these structures on the outside that no one knows what they are, and they confuse some people sometimes. Okay, let's start on the real brain, on the human brain. Sorry. So we have all of these hills and valleys on it. This here is a valley. This here is a hill, valley, hill. Sorry, yeah, hill, valley, hill. So you see these. You see all of this here. This is what a brain looks like in your mind. This is a brainy stuff, right? All of that stuff here. That region of the brain here is the cerebrum. Okay, and that's one region. There are other regions in the brain. You have this in the back of the brain. That's the cerebellum. And then if you open the brain, there's the brain stem. You can hold the brain with it, right? So that's the brain stem. And then you have this region that not a lot of you, even if you studied it before, you might have not heard of it. This is the diencephalon. Right here. There's a bunch of structures that you need to know that it has, but we only need to know two. We're going to go over this in a second. So these are all the regions of the brain, the major regions of the brain. The cerebrum, cerebellum, diencephalon, and brainstem. The cerebrum, as I said, has all these hills and valleys. The valley is known as a sulcus. Plural of that is sulci. And the hill is known as a gyrus. The plural of that is gyri. Okay?
Are you going to do them plural?
You can give me...
They're all like...
Yeah, so you can say gyrus, gyri, or sulcus, sulci, doesn't matter. It's like saying nucleus, nuclei. Yeah. Or foramina, foramina, there's... Okay, so... all of these together, if you see a bunch of sulci and a bunch of hills, like when we label them, we'll put sticker on many of them. These would be convolutions. So because they're all convoluted on each other. So when we put a combination of structures here and say, what are those? Like, what are those? These are the convolutions. They are a combination of structures. So if we ask it on the practical, you'll most likely get this as a combination of structures. Okay?
That just includes the hills and valleys.
Hills and valleys. Multiple hills, multiple valleys. If there's one of them, sulcus, gyri, gyrus. Whatever.
So it'll be pinned in several places.
It will be pinned in several places. If the tape goes, in a circle of some sort.
Okay.
Here, like I want this region here, or this combination of structures. Okay. However, we are not that nice of people. There are specific gyri, there are specific sulci that you guys need to know. The specific sulcus that you guys need to know here is labeled as number 5 with an arrow on it, on the brains that you have. This right here is the central sulcus. So this is a specific structure. If I ask you to identify the specific structure, or even if I say structure and I'm pointing at this, you know for a fact this is the central sulcus. It's not just a regular sulcus. It's fancy, it's the central sulcus. And then you have, this is the front of the brain, right? And this is the back of the brain, right? Because you know the cerebellum is here, so that's the back of the brain. That's the butt. This is the front. In this case, you have this gyrus, and this gyrus. This gyrus here is the precentral gyrus, which is labeled 6 on your brains. And this gyrus here is the post-central, behind or beyond the central, so it's post-central. Yes? Don't memorize the numbers, they'll most likely be hidden, or we most likely will use this part of the brain that has no numbers and not use the part of the brain that has numbers. That is most likely the case, so I would not recommend memorizing numbers. Yeah, you have, this here is the central sulcus, this here is the precentral gyrus, and this here is the post-central gyrus. Okay? But then we have other specific sulci, like the lateral sulcus right here on the side, or on this side. This is the lateral sulcus, laterally. And then you have, although it looks like it's made up, but this is the parieto-occipital sulcus. Now some of you should understand that this is from the skull, because the skull has the frontal bone that covers the frontal side of the cerebrum. The parietal bones, if you remember them, they cover this parietal side of the cerebrum. So this is the parietal, this is the frontal, this is the temporal from here and here. And then this is the occipital. If you remember that from the skull, the bones that were covering this. So in this case, lateral sulcus is separating between the parietal and the temporal. This is the lateral sulcus. There's another lateral sulcus here, parietal, temporal. And then you have the parietal occipital one right there, which is separating between the parietal and the occipital. Okay? Any questions on these sulci or gyri?
Can you do the last one?
This is the parietal occipital sulcus. So right there, it is separating between the parietal and the occipital. On the new brains, you might not find it. On the older brains, like these ones, you will find it. So just know it this way. Okay. And then we have gyri and sulci and convolutions, and we're going to bring in something else. Fissures. If you remember what a fissure was, a fissure is something deep, right? Something cuts. A sulcus is like a river, a fissure is like a huge valley. Okay? So we're going to go with this right here. This is the longitudinal fissure. And between the actual cerebrum and the cerebellum, and I'm not going to put this together right, this right here that separates the cerebrum from the cerebellum, this here is the transverse fissure. Whatever separates, no, that's fine, separates between this, which is the cerebrum, and this, which is the cerebellum, is a transverse fissure. Fissure is always deep, always remember that. Okay. On the newer brains, you might not see it very well, but there's the fissure that I was talking about, the transverse fissure separating between the cerebrum and the cerebellum. Any questions on any of this so far? Okay. On the sheep brain, it is literally impossible that we can pin the central sulcus, the precentral gyrus, and the postcentral gyrus. So guaranteed, those will be asked on the actual human model and not on the sheep brain. However, you can see the transverse fissure that separates between the cerebrum and the cerebellum. And you can also see the longitudinal fissure, which is basically separating these cerebral hemispheres. This one and this one are the cerebral hemispheres as the whole thing. The parietal, the temporal, part of the frontal, part of the occipital. This is a cerebral hemisphere, and this is a cerebral hemisphere. However, you don't need to know right from left on this, because most likely it will be labeled like this, where there's a tape going over all of them, and you will know that this is the cerebral hemispheres, because we're going to say identify the structure, versus if we label this way and say identify the region, that is the cerebrum. Okay? Region versus structure.
So how would
This
you
is a lot.
how would you label a hemisphere?
Take
No, I'm saying the line,
the fissure.
the central sulcus. You wouldn't put it like that.
I would put a sticker and then put a lot of arrows going towards the sulcus
Okay, I was
itself.
making sure, like, so we could distinguish
Yeah.
between the structure.
And again, if you feel stuck or trapped on the practical where the labeling makes no sense, you should always call us to your stations so we can help you with that.
How would you label a hemisphere?
The hemispheres are structures, a structure based cerebral hemispheres.
Okay.
And we just put a tape right there. I wouldn't really worry about how we would label things, as I would label as something and they would label something. If you're stuck,
Okay.
always call me. Okay. Any questions on any of this? Not so far. Good. Sulci and gyri, like regular stuff. The black stuff here would be the sulci, and the brown, just brainy stuff, would be the gyri. Black versus beige. Yeah.
We don't have to be able to distinguish like the central sulci on.
Just said that. Yes, you don't. You only do it on the actual human model.
Okay.
Okay. All right. So now the one cut that we're going to do on this brain is we're going to cut this longitudinal fissure completely. We're going to separate the brain into two halves.
Don't hacksaw at it. Just
Well, because this is the worst.
not you.
Oh, I'm sorry.
I'm just saying in general. Why? Like cut it like butter. Not
You don't want to disrupt the
Like a
tissue.
steak.
You don't want it to look like a steak. But if you can't, because these are not the best scalpels, don't worry about it.
And we go all the way through.
All the way through, we're cutting it right in half. So you can also cut the chiasma now. These These are the worst scalpels in the world. It's like, I can't even cut myself.
Ah,
Susan.
oh my gosh.
Okay. Again, these are the meninges. They will be labeled like this. Don't forget this, the meninges found on the sheep brain. Okay.
Wait, Arby. You put this stuff in there too?
Cut all the way, yeah. Just separate it into two halves.
Yeah.
Separate it like this into two halves. And don't worry about the quality of the separation. That's why I kept it here in front. Make sure no one touches it. Okay. I hope everyone got it cut in half. Here's what I'm going to do. I'm going to put the actual human model and the sheep brain, and we're going to talk about this. Again, the regions: cerebrum, cerebellum, brainstem, diencephalon. Again, here you would see the cerebrum. I'm going to hold it up. Cerebrum, cerebellum, brainstem, diencephalon. Okay? Diencephalon would be white. It's really indistinguishable from the brainstem on this sheep brain, but I'll show you how to distinguish it. Okay. One structure that hits a lot of people is the corpus callosum. This is the corpus callosum right here. It's pretty large. And this is it on the sheep brain. This one separates the cerebrum from the diencephalon. It's just the border of the cerebrum and the diencephalon. And you can see it here as well. If you follow this guy, if you follow the corpus callosum, this is the front. Remember, this is the front, this is the back, because the back has the cerebellum, front doesn't. So you're going to follow it front to back, and then you're going to cross the street. Right there. Follow it front to back and cross the street. The structure's number is 23. I wouldn't memorize number. This is just for you to know now. This is the pineal gland. Pineal or pineal, whatever you want to say. This is it right here. Structure number 23. So, as Jason is pointing out right now, we're going to go from the front towards the back, and we're going to cross the street. The pineal gland in the sheep brain is much larger than in our brain. They sleep a lot.
Wait, where's the pineal? Sorry. On the sheep.
On the sheep. So you're going to go with the corpus callosum just like we did. We're going to go from the front all the way to the back and cross the street. Right there.
Okay.
So as you see, this is the pineal gland of the humans. This is the pineal gland of the sheep. They sleep a lot. Okay. Another weird structure that we're going to talk about is the colliculus or the colliculi. If you go plural, number 31 on your human brain, right there. You have, this is the inferior colliculus. This is the superior colliculus, and under the pineal gland, under 23, you got two structures here. They're labeled 31. You have the superior colliculus and the inferior colliculus. If you look at it this way, you'll see two mountains or two hills. This hill and this hill. So this is the superior because it's on top, and this is the inferior because it's on the bottom. And on here, you'll see it as well. This is the superior, and this is the inferior. Two hills. It's like a little butt. Okay. This structure right here, the bean-looking structure, this is your pituitary gland. And it's attached to your brain by this line here, by this ligament, the infundibulum. So infundibulum attaches to the pituitary gland. On the actual brain, the pituitary gland is pretty large. The infundibulum is really hard to find. So I'm going to try to do this. This is the pituitary gland on the brain. Extremely hard to find the infundibulum on here. So we're just going to make most likely, if we point at the infundibulum, we'll point at the human model.
Is it just like that string?
This is string, yes, a ligament that connects the two. And this is it right here. This is your pituitary gland. How? The black part, the big black part right there. So like, yeah, cut it in half though. Yeah, so in yours, yours just didn't cut that little. That's fine. You see here,
What's the black stuff around it?
I actually don't know.
Do you feel that?
Okay. In the cerebellum, we have a really nice structure called arbor vitae or arbor vitae. It's the tree of life. This is it, the white tree right here with all the branches. And you can also see it here in the cerebellum. This is it. No, that's the arbor vitae or arbor vitae, the tree of life. It's right here on the sheep brain. It is right here on the human brain. Are we all on the same page? I see one hand raised up. Are we
Yes.
all on the same page? Should I continue going?
Keep going.
All right. The brain stem is this one right here. The brain stem has multiple different structures within it. You have the midbrain right here. You have the pons. You have the medulla oblongata. Okay? These bulges right here are a really large bulge, and I just said bulge. And this really small bulge, this is the pons. Under it is the medulla oblongata. And this in the middle, right in the middle of the brain, is the midbrain. So midbrain, pons, medulla oblongata. These are structures of the brain stem. The brain stem is the major region. On here, this is the midbrain. And I did a horrible job cutting it. This is the pons. This is the medulla oblongata. Just know them as their direction. 1, 2, 3. Midbrain, pons, medulla oblongata. Some of you, if you cut it in half very well, you'll be able to see these bulges. But they're not as defined as on the human model. This is a bulge, and this is a bulge. Bulge, bulge, bulge. Okay. The diencephalon is one of those structures that has one of those regions that have a lot of things in it. You don't need to know everything. You only need to know 2 things. The thalamus and whatever comes below the thalamus, which is the hypothalamus. The thalamus is labeled 20 on your models. And the hypothalamus is labeled 21. This is the thalamus. This is the hypothalamus. The hypothalamus is always towards the front. The hypothalamus is always towards the front. So this is the thalamus. This is the hypothalamus. 20, 21. On here, this is the thalamus. This is the hypothalamus. Always towards the front. Thalamus, hypothalamus. Thalamus.
What's the vein?
Below it to the front.
And just in the small section or the small section?
So that small section right there, this, if you're talking about this is not it. This is it.
That's it?
This is the thalamus. This is the hypothalamus. This is the chiasm. So it's separated. So this is what you need to worry about. Okay?
Oh, no, yeah.
Got it? All right. No guarantees, but we've done it in the past where we would put a reference pin if we're doing it on the actual sheet. We'll put 2 pins, we'll put one here and one here. We'll be like, okay, identify one of the structures. So you know that that's the thing. However, if you're stuck on the practical, please call me to your table and I'll tell you whether there's 2, am I pointing at the top one or the bottom one, because this is really confusing if we put it on here. However, on here, you have no excuse. The thalamus is separated by this indentation right here from the hypothalamus. Okay? Any questions on any of this?
No, sir.
Okay. I am done with the brain. The one last thing that I'm going to say on this is we put this back together, and I'm going to end it on a joke, I guess. Put this together. What do you see here? This is the cerebellum, right? See that butt? That's the butt crack right here. The butt crack is the vermis.
Crack is the vermis.
The butt crack is the vermis. It separates the two cerebellum. Cerebelli. Bellami. Cerebellums. No, it's actually cerebellums. On the sheep, you do not find the vermis because we have one cerebellum. So we can't find the vermis. So it's only on the human brain.
Oh, that's just right there.
Wait, what about the living?
I went over, so I said frontal lobe, like where the frontal bone was.